Hi, Manuel. My name is Manuel Sánchez. I am head of San Fernando Laser Station. In the next few minutes, I will talk about the progress of my thesis the last academic year. This is the index I will follow: an introduction of the thesis, the motivation that the motivation of the thesis, the current state of the art, the goals and methods that I have been applying during this analysis, the methodology and results that I have been working this time, and the current tasks and finally activities and achievements in last year. The space debris problem poses a risk to operational satellites and the environment of the space due to the risk of collision at high velocity. This collision with operational satellites could generate also a additional problem, that is the generation of most debris due to a cascade syndrome called Kessler syndrome. This generation of space debris threat to the space exploration and the future missions, and also have impact on communication and terrestrial service like GNSS and other constellations that rely on satellites. Below, I would like to highlight some numbers about the space debris problem, and also an estimation based on ESA master application that quantify the number of space debris in Earth orbit around 140,000 millions. What is the motivation of this thesis? The official version is the influence of scientific studies to investigate this problem and try to mitigate the effects of the space debris. And the real one is that my observatory tried to not only provide data, but also analysis. I start to analysis our own data and participate in scientific studies in this field. There are also more ways to mitigate the space debris problem, like active mitigation to reduce generation of space debris based on international cooperation, and effective orbit management, establishing rules and regulation to ensure monitoring of objects on orbit. Practice and control debris removal to decrease the amount of existing space debris, and also promote awareness and education, fostering a mindset of sustainability in all space activities. Here I would like to highlight some milestones about the space debris problem that gained relevance in the late 2000s. Also, if the launches of satellites stop right now, will continue to grow the generation of space debris. For this reason, it's necessary to implement mission to removal these from satellites, and also apply guidelines to disposal space debris, like, for example, the transition to graveyard orbits at the end of the mission in geo orbits, and also make re-entry after 25 years at the end of the mission. And also it's important to consider the challenge that suppose the mega constellations in the next years. Talking about the orbit determination of space debris, I would like to remark some key points that is based on several parameters, like the length of arc observed, the type of sensor, the accuracy of each sensor, and the number of observations. In 2030, it's important to say that was the first observation by SLR station made by Graz and Shanghai station that is useful to complement the SST task made for telescope and radar. The contribution of Lassen ranking is valuable because it is possible to provide measurements with less than centimeter accuracy. And also in this problem, you have to consider different types of algorithms, to estimate algorithms, sorry, and the importance of the covariance propagation. This is the goal of the thesis related with the combined use of the three types of sensors: radar, laser, and telescopes. All the goals are related with implement and develop algorithms to apply this technique. Also related with other studies related with laser ranking data. When you start to apply this method, can be a little bit problematic because the orbit determination is highly non-linear. This is that you can describe the state derivative as a linear combination of the state variable. All measurement instruments have errors due to the configuration of their sensors. And also you can match perfectly the model with the reality of the environment. The solution to this problem is the linearization of the system based on orbit determination using differential correction, model the measurements of the errors of each sensor, and simplify the model applying process noise. How can you linearize the system using the state transition matching? That is the relation between the derivatives states in two correlative times. You can use in this particular scene the station transition matrix. As this is a dynamic system model, non-model forces can be taken into account, and you have to use a process noise. And a particular profit of data fusion is that you, when you have orbit determination, your final result is a region of uncertainty due to this process. When you have an individual observation from a sensor, you have a region like the red one. When you combine in simultaneous observation, you can combine the red one due to, for example, for a telescope, with other region of uncertainties, and you can reduce the combined result in the yellow one region. That is the combination of the different observations from different sensors. When you apply the estimation, you can choose different types of estimator, like the nonlinear least squares or the Kalman filter. For the first one, you have to study the covariance matrix, the sign matrix with the derivative terms, and the weighting matrix of each sensor observation. And you try to minimize the sum of the square residuals. In the Kalman filter, there are two phases. That is the prediction based on the equation that model the environment. You correct this prediction with which is measurement you have in your observations. There is an iterative process that you can update the prediction with your observation. Having test these two estimators, I have a trade-off that comparing the two estimators. The least squares is easy to use because you have fewer inputs to set, while the Kalman filter you have to make a more difficult configuration of the filter. In least squares, you cannot detect maneuvers because you process all the data that you have during the observation. While the Kalman filter, as you process the data in each observation, you can detect different trajectories due to the realization of a maneuver of the satellite. Talking about the Kalman filter, you need to apply linearity of the system, but there are different an extended Kalman filter that use a expansion series of Taylor to linearize the system and apply after that the filter.
Manuel, you have to
okay.
accelerate a bit.
Yes, 2 more slides and I finish. Talking about the other tags of my thesis, I have developed a study about the attitude and speed period of the space debris using kilohertz laser. For this problem, you have to combine the files from the laser ranking, the CRD, with the precise ephemeris using an SLR, that is the CPF. That have more precision than the TLE. If you compare the residual from a TLE that is around the hundreds of meters with the residuals from a laser observation with a TLE have a difference from hundreds of meters. The CPF is more precise, and you can get a precision of the order of meters. This is the procedure to apply this study. You have to make an interpolation of ephemeris in the instant of the observation, applying a 9-degree Lagrange interpolator. After that, you have to make a correlation of the observation, the tropospheric delay, the station delay, the center of mass, erase random and systematic errors. And finally, you can analyze the residuals, and it's possible to see the modulation due to the distance between the rotation axis and the laser retroreflector array. After that, you have to make an spectral analysis using Lom's carrier algorithm. You can find the mean the mean frequency of this period. In the both final image, we have get the trend from 2 different satellites, the Fund satellites, the ENVISAT, and also the TOPS Poseidon. This work is on review for presenting in a journal. And my current task is about the last proposal that we submit for ESA, that is to implement coordinate observation between different sensors using telescope, radar, and laser station. Implement coordinate observation to make after that data fusion. This project is co-directed by University of Sevilla and the observatory, and we are waiting for the approval. And this is the activities I have been participating last year related with SST, and the articles I submit, the one on review, and 2 of them about divulgative related with space. And also I tutored 2 final degree projects, one of them for the University of Cantabria and the other one for the University of Sevilla. That's all for my side.